Alright, we're going to continue the movement tutorial for catlikecoding. This is a new section within that tutorial called surface contact. So it seems like it's going to deal with, well actually I don't know the entirety of it, but what we're going to deal with today is making it so that our character doesn't hit slamps like a ramp and like fly off. It'll kind of stick to it and move up and down it as if it was like a person walking on it rather than a ball rolling along it. Yeah, so that's what we're gonna start off on. We're gonna have to build a test scene here real quick. So it would be nice if we could get that like sharing thing set up somehow. But I don't know if that's gonna be like too big of a project.
Yeah, it might be. How much are we actually building though?
It's not much, but I just think this is a good excuse to learn that, but it doesn't really matter. All we really have to do is just build a couple little steps like this. You can see on my stream right now.
Yeah.
So it's not too bad. Seems like we might even be able to, well, no, actually.
Does Pro Builder have a stairs thing? Pro Builder stairs. Yeah. Wow.
Oh, was this just a stair, like, pre-built thing he did?
I don't know if this is... This doesn't seem... Oh yeah, it is Pro Builder. Cool. So I guess Pro Builder window, new shape, stair. Okay. Very nice.
Oh, you can even make them curved stairs? Damn. Like spiral staircase. That's pretty nice. So it's not quite the same scene he made, but we could kind of do something like this.
Oh, those are the step sizes.
So yeah, if we just make like a rough approximation of it, it's probably fine. So you said that he, on the one that's supposed to be completely flat, it still hits a little bump because there's like a vertice there that isn't blended. And he did that on purpose to produce ghost collision, just to like teach us about that, I guess. So I do have that as well on my example. We'll see if that happens. Yeah, this is just a fucked up like obstacle course.
Okay. When our sphere reaches the top of a ramp, it goes flying due to its upward momentum. This is realistic, but might not be desirable. A similar thing happens when the spheres bump into sudden small elevation differences. I made a test scene that demonstrates this for steps up to 1 unit high. When approaching with enough velocity, a sphere will bounce if the step isn't too high. In the test scene, this happens a little for the flat plane, but because I made it by reducing the step height to 0 without merging the vertices, test scene, this even happens a little for the flat lane, because oh, okay. That produces what's known as a ghost collision. Scene geometry should be designed to avoid that, but I kept it and pointed it out. In real life, there are various techniques to keep something stuck to the ground. For example, Formula One race cars are designed to convert airflow to downforce. Okay. So we're just writing a different thing for that color bit. Let's consider the moment a sphere would get launched off a ramp. To keep it stuck to the surface, we'll have to make adjustments to its velocity, realigning it with the surface. Let's examine exactly when we'll receive the information that we need. We'll make the sphere white when it's not on the ground by adjusting its color and update based on ground, similar to the coloration demonstrated at the end of the previous tutorial. So he puts it in update? Or was it before?
Thought it was already an update.
Oh, okay.
So I kind of have a version of his thing going here. You could see that when I go over where the vertices, like, or the edges where it's like supposed to be flat, but there's an edge there, the ball like flashes because it's getting two different normals for that 1 second. So that definitely would be a problem. Yeah, if I get enough momentum and hit it, it like hits like a jump like that. And the idea is we'd want him to just like step up the staircase, not like fly over it like that. Okay. Let's consider the moment. Oh, did you already read that?
Yeah.
Okay. So is this this isn't replacing anything, is it?
It replaced the little renderer, the color changing thing we had before.
Oh, okay. Oh, but that was optional, huh? That's why he didn't include it as like crossed out.
I guess so, yeah.
So it just, the color is determined by whether or not it's on the ground.
Yeah.
That's a smooth way to do it. Yeah, even when I go over you can see it when I go over the edge right there. What did he call it? Phantom collision or something?
Ghost collision? Let's keep track of how many physics steps there have been since we considered ourselves grounded. Add an integer field for it and increment it at the start of update state. Then if it turns out that we're on the ground, set it back to 0. We'll use this to determine when we should snap to the ground. It can also be useful for debugging.
Steps since last grounded.
I tell you, my house could use debugging. These termites are chewing up the walls.
Probably call catlikecoding for that.
I'm serious. I'm serious.
Oh, go for it, dude.
They're chewing up the walls. The foundation. They're going crazy.
It's called Charter. No, wait, they do internet. Those bug guys.
Herder.
Gerber?
Out here, it's Gerber.
They do bugs and babies?
Just bugs out here. That's what we consider them.
Okay, I don't know what this is.
What? What we're doing?
Yeah, what are we...
So it says the physics step during which the sphere gets launched still has collision. We act on that data during the next step, so we think that we're still grounded while we no longer are. It's the step after that when we no longer get collision data, so we're always going to be a little bit too late, but this isn't a problem as long as we're aware of it. So we're keeping track of how many steps, how many how many times update state has fired since the last time it collided.
So for one update state, it's still, like, considered grounded even though it's in the air?
I don't know. For one update, no, I mean it's either way. So it updates. The first line is it just increments it, saying like there's a step of 1 that's going to happen within this next update state. There's going to be one step. We're adding one step. And then right after that, if it turns out it was on the ground, then you set it back to 0 because it's been 0 steps since the last ground. But if that's not true, then it'll increment again. And it'll keep doing that until... But we're going to use that number for something.
Okay. Maybe we want to see what we're using the number for. It might sink in a little more.
Add a snap to ground method that keeps us stuck to the ground if needed. If it succeeds, then we'll be grounded. Have it indicate whether this happened by returning a boolean, initially just returning false.
So this is kind of... This steps since last grounded is kind of like keeping track of how long we've been in the air?
Yeah, basically. How many physics steps have taken place. So it's just we're accounting for our delay. But we have a boolean that just says whether or not we are snapping to the ground.
So that's making it so that we can turn off snapping to the ground on or off, or is that something we're just going to use it later?
I don't know.
So it could be nice if we could like toggle that off, because then that would be, I guess if you wanted to do like a skateboard mode or something, you could like hit jumps.
So we conveniently combine it with the on ground check and update state using a boolean or. Oh, okay, for some reason I read that as and, but that wouldn't make any sense. So if it's on ground or it's snapping to ground, then step since last grounded is set to 0.
Okay.
Snap to ground only gets invoked when we're not grounded. So the amount of time or the amount of steps since last grounded is greater than 0. But we should only try to snap once directly after we lost contact. Thus, when the amount of steps is greater than 1, we should abort. So bool returns false if the step since last grounded is greater than 1. I don't totally get that, but I also don't totally get the snap to ground method yet.
See, I think raycasting, this is going to be a big thing too. We're probably going to use that a lot, right?
Yeah.
That's like hit scan, interacting with things, picking up physics objects. That's how you would probably do the pool throwing thing, right?
Yeah. Definitely.
Oh, okay, okay. So that third parameter would be how you would grab that and then compare it to say, like, is that like an enemy or is it like an interactable object or whatever?
Yeah.
Okay. Where is this going to go? That's in snap to ground? Yeah.
We only want to snap when there's ground below the sphere to stick to. We can check this by casting a ray from the sphere's body position straight down by invoking physics raycast with body position and the down vector as arguments. Physics engine will perform this raycast and return whether it hit something. If not, then there is no ground and we abort.
So I'm assuming this is just like a placeholder thing right now. Like, why would it? Why is it returning false if it hits?
If it doesn't hit.
Oh,
That's
the
with
exclamation part.
exclamation.
Okay.
Yeah. Are you getting an error in the bool for steps since last grounded?
No.
Oh wait, no, I'm stupid. I missed a thing. Yeah, should be good. How does that code work? Raycast hit is a struct, thus a value type. We can define a variable via raycast hit, then pass it as a third argument to physics raycast. But it's an output argument, which means that it's passed by reference as if it were an object reference. It's an argument, okay, that is passed by reference because it isn't there yet, so it's just the reference to its place, as if it were an object reference. This must be explicitly indicated by adding the out modifier to it. Okay. So out is like an output slot that doesn't necessarily have something in it.
So should we put a check generally? I mean, I'm not to like try to correct this guy, but like generally would it be like we'd put a check to make sure that it's like a valid value before we try to do anything with it, or would we just
Which value?
the raycast hit? Like, should it be like, is if raycast hit is just nothing, then it just returns false, or should we have it like? I guess it depends on the usage.
Well, let's see. The hit data includes a normal vector. Yeah, we save it right here. Hit.normal. So within this loop, we can reference hit.
Okay. So if the normal in the y direction of the hit object reference that we got from the raycast is less than our minimum ground dot product, which was already calculated before.
Yeah, and it's just the normal of our minimum ground angle.
Okay.
So we control that. The dot product.
So we're setting the ground contact count to 1 because we just know it's only one, like it's hitting the floor now, so it's just one contact. Like, what if it?
You said ask that again.
I'm just confused. Like, ground contact count is what was controlling the color of our sphere before, whether it was like getting multiple normals or not. Mm-hmm. So we're just setting it straight to 1, but what if it gets snapped down in like an indent where it's hitting 2? Would it just automatically update back up to 2 now, or that wouldn't be a problem?
Set contact count. Where is it?
Under realigning with ground.
I mean, but it's in the Boolean.
Oh,
specifically.
Yeah.
So I don't know if it would get called. I think it's like snapping is on, so you'd want it. You couldn't snap to 2 at the same time, probably, unless you did an average thing, which I don't know if he cares to do.
Yeah.
I think he wants to snap to 1 and then the other.
Okay. So it sets the contact count to 1, and then it sets our contact normal to the normal of the hit raycast. Okay.
Now we consider ourselves to be grounded, although we're still in the air. The next step is to adjust our velocity to align with the ground. So that was just setting up a check.
Oh, so it didn't actually change the movement.
It's just a Boolean that tells us that we're snapping to ground.
So if I run it right now, when I go in the ground, when I go up in the air, I should flash white for like 1 second and then turn black again or something? Oh, never mind. Whatever. I guess they're probably not actually connected to that yet.
Float speed. So the next step is to adjust our velocity to align with the ground. This works just like aligning the desired velocity, except that we have to keep the current speed, and we'll calculate it explicitly instead of relying on project on contact plane. So instead of projecting, we're just getting the dot product and multiplying it. Or I don't get that velocity minus hit normal, but that's just calculation.
So we're getting just the magnitude of the velocity, not the direction, right? Because that's the idea for the speed, and then we apply the direction within this velocity function where we like redefine it. So that way we have the same like velocity and everything, but the direction of it changes.
Yeah.
this point, we're still floating above the ground, but gravity will take care of pulling us down to the surface. In fact, the velocity might already point somewhat down, in which case realigning it would slow convergence to the ground. So we should only adjust the velocity when the dot product of it and the surface normal is positive. So is that this? Again, is he saying like if the slope was going kind of downhill already, but there's a bump? I guess that if is kind of confusing me. I don't know what like situation that's avoiding.
Velocity might already point somewhat down, in which case realigning it would slow convergence to the ground.
So what if it's like that, I guess, and the ball's rolling down, and then it realigns the velocity, but it's like already downwards. So I guess normally the ball goes like that, and then it realigns the velocity to be just that. So wouldn't it just do that then?
You would always assume that the dot product is greater than 0. So it's like not an invasive check or an invasive if statement, I feel like.
Okay.
In which case realigning it would slow convergence to the ground. I guess it means if you're pointing down, if you drop down, your velocity vector is pointing down when you are, if you're in the air and then you drop down, right?
Yeah.
So if you hit a slope and then I guess realigning it, it would realign you to the ground because it's snapping, but it would slow you down, I guess. Like turning the thing while you're pointing down is, I guess, a problem that he found.
Okay. Oh, there we go. That already works on the steps. It just kind of walks up the steps.
We take the speed.
Oh, wait.
The velocity magnitude. Then the dot product of the velocity and the hit normal. Okay.
Jumping doesn't work anymore. I'm sure he's going to go over that, but I just noticed it. If you jump, it recasts you, it like snaps you to the ground still too. So it's just if you're in the air at all and there's like a thing below you.
Oh.
That's what it seems like, at least. Unless I fuck something up. Does he acknowledge that? Okay, yeah, he does acknowledge that. Okay. Note we're only considering a single point below us to decide whether we're above ground. This works fine as long as the level geometry isn't too noisy nor too detailed. For example, a tiny deep crack could cause this to fail if the ray happens to be cast into it. Does he give a fix for that? Or that's just like a known issue? It makes sense that at high speeds our sphere gets launched anyway, so let's add a configurable max snap speed. Set it to the maximum speed by default so snapping always happens when possible. But then if we go past that speed, then it'll send us flying? That's the idea?
Yeah, I think so.
Okay.
That's pretty nice. Being able to go from like full physics to no physics, Or not no physics, but to snapping.
Yeah. I was trying to think of like a mechanic where that would be helpful.
I mean, that's the GTA thing. Right? Like, at a certain slope, it becomes a ball.
Oh, like at a certain speed, you'll just start flying rather than having like actual control over it.
Yeah. Like when you stand on a car and then it speeds up at a certain speed, your guy becomes a physics object. Anyway, let's put that snap speed. And then return false and snap to ground if speed is greater than max snap speed. Okay.
So we set the max snap speed a little bit higher or lower than the max speed. Okay.
That actually could be really great if it's a character that's running and then at a certain speed you'd want them to slide across the ground when they stop inputting the run.
The snap speed would deal with that?
Well, I guess it's a very similar method.
I guess I can see that, yeah.
Because it would snap them, like a slide is just snapping them to the ground.
Okay, so if I set it to 11, that means I should never, like, how would I get fast enough to even do that if my max speed is 10, right? I guess if something, like, pushes me or something like that.
Yeah, probably. Or starting from really high and falling.
So now if I go over the edge, if I put it to 9, I could just go over the edge kind of slow and it won't matter. But if I go full speed, then I'll like fly over it like a ramp. That is nice, yeah. Okay.
We're snapping when there's ground below the sphere, no matter how far away it is. It's better to only check for nearby ground. We do this by limiting the range of the probe. There is no best maximum distance, but if too low, snapping can fail at steep angles or high velocities, while too high can lead to nonsensical snapping to ground far below. Make it configurable with a minimum of 0 and a default of 1. As our sphere has a radius of 0.5, that means we can check up to half a unit below the sphere's bottom.
It's really smart to be setting up all these like fields like this, having them all be configurable.
Yeah.
Like this would be such a pain if it's like every time we wanted to check something like this, we have to like rewrite the code or like manually do it in there. Here, like once we have the character like script down and we want to deal with like level design, and if there's like a tweak we got to do, it seems so simple to just come in there and fix.
Add the distance as a fourth parameter to physics raycast. Okay. So fourth is the range, I guess. Which is that's pretty nice.
That is very convenient. I like that. Just a question of if I'll remember that or not. I guess I could just bring up the raycast like documentation and it would tell me that. When checking the ground to snap, it makes sense that we only consider geometry that could represent ground. By default, the raycast checks anything except for objects put in the ignore raycast layer, which shouldn't count, can vary, but the spheres that we're moving most likely don't. We won't accidentally hit the sphere we're casting for because we're casting from its position outward, but we might hit another moving sphere. To avoid that, we can set their layer to ignore raycast, but let's create a new layer for everything that's active and should be ignored for this purpose. Go to the layer settings, either via add layer option of a game object's layer dropdown or the tags and layers section of the project settings. Then define a new custom user layer. Let's name it agent for generic active entities that aren't a part of the level geometry. Okay, I hadn't learned about layers at all, so this is probably good. So when he says we go to add layer, is that just game object add layer, or do I right click the object? Where did you get that?
I don't know about the add layer, but I guess it is under the game objects layer drop down. I did it under project settings and then tags and layers. Although I don't actually know where we add a new one. I guess it's just there are a bunch of empties. We fill those. Okay. So user layer 6 is going to be called agent. And then on the sphere, we change its layer to agent. Then add a configurable layer mask probe mask.
I haven't even found layers yet.
If you open project settings, so edit and then project settings, what I do, can you see this, or is it on?
I think I can see it.
Is it on Visual Studio or Unity?
Oh, it's on Unity.
Okay, good. The project settings like pop out normally, but you can drag it in next to Inspector, and it's a nice
okay.
place for it. But it's under tags and layers.
Okay. And then I create a new layer here.
There's a bunch of these empty ones, so you just fill an empty one with.
Is 3 empty for you?
Yeah, but I would maybe ignore that one.
Okay, I'll just do the same. I'm just gonna do 8. I'm just gonna do the one he did, just to be sure.
I don't know what a layer mask is. Layer mask probe. Layer mask probe. guess it just is. It chooses what layer this is on.
So you could have it like switch between layers on the fly kind of deal?
I guess. But this is specifically just to... What was it? By default, the raycast checks anything except for objects put on the ignore raycast layer. What shouldn't count? What shouldn't count can vary, but the spheres that we're moving most likely don't. We won't accidentally hit the spheres we're casting for. Our position raycast. So instead of just setting them to ignore raycast, we're just creating a new layer that does basically the same thing, so that we can we could add other things to this layer. This is our active layer, I guess.
Okay.
To apply the mask, add it as a fifth parameter. So the fifth is the layer. Wow.
So we're telling the raycast, like, follow the rules of this mask, like only apply to things.
Just do the. I think the layer mask is literally just like what layer. It's just like which layer slot. Like a layer mask is just. It just says what layer. Like that's it. Just what layer. Because at -1, it counts for all of them, and then the numbers. Although I don't know where we actually choose it, because it's set to -1. Doesn't look like he changes it. Oh yeah, but he goes way more into that.
Okay. Well, is there a way that we can like demonstrate what the what the max snap speed changing really does within like I guess no, because it's just the probe mask is just so that we only consider specific things ground, but all we have in this test layer is just ground, so we can't really do anything with that. And then the snap speed we already did with going off the ramp. I think it was probe distance that I was like hoping we could have like a visual aid for, but I don't think there's really a way to do that.
No.
Okay, well, whatever.
I guess if you started it up high and then made a check or something.
That would have to come down to when we're like actually testing out a level and it's just like, oh, this is snapping too soon, we should adjust it. Okay. Snapping now works and is configurable, but it also activates when we jump, negating upwards momentum. To make jumps functional again, we have to avoid snapping directly after we jumped. We can track this by counting the physics steps since we last jumped, just like we count the steps since last grounded. Incrementing it at the beginning of update state and increment it at the beginning of update state and set it back to 0 when a jump activates. Okay.
Step since last jump. So you just add it and then set it to 0 when you jump. Makes sense.
So it's just effectively the opposite of steps since last grounded. Now we can abort snap to ground also when it's too soon after a jump. Because of the collision data delay, we're still considered grounded the step after the jump was initiated. So we must abort it if we're 2 or fewer steps after a jump. And where is this if statement? Is this in snap to ground? Yes, it is. Okay. Okay. That's pretty good.
Okay. Let's next consider a more difficult kind of surface, stairs. Realistically, spheres can't roll up stairs very well, if at all, but we might want them to do so anyway, maybe because they represent something that should be able to navigate stairs. I made a test scene containing 5 45-degree stairs with step sizes 0.1, 0.2, 0.3, 0.4, 0.5. With default settings, the spheres can't handle the stairs at all. At max acceleration, most manage to ascend, but the results are unreliable and bouncy, no smooth movement at all. Trying to move at an angle instead of straight up the stairs is almost impossible. Large stair steps make movement impossible, and while it is possible to bounce up stairs with small steps, collisions become arbitrary and motion becomes jittery instead of smooth. Rather than trying to fight against the physics engine, we'll be pragmatic and make its work easier. We want smooth, consistent, controllable motion on stairs. We can get that when we use flat ramps instead, so let's replace the colliders of the stairs with the ramps. Oh, okay. So this is just, I for some reason I thought this was like averaging the...
Yeah, this is just like level design.
Yeah. But I think the idea is that if you scroll down, the 2 ways of colliding with stairs. I think the idea is you can collide with things that are interacting with the stairs differently. I don't know how. Let's see. Disable the mesh collider components of the stairs, but don't remove them at this point. Then temporarily increase the max ground angle to 46 degrees so the spheres can move up the 45-degree stairs. While it requires some additional level design work, using simplified colliders for stairs is the best way to make them navigable using physics. Okay, so that's just a tip. We should just remember that. So we'll stick with this approach. But it is an approximation, so on close inspection you'll see that the spheres both cut through and hover above the stair steps. However, this usually isn't that obvious from a distance and while in motion. Can we avoid slowly rolling down stairs? We'll deal with that in the future. that we use a simplified collider for sphere-stairs interaction doesn't mean we cannot use the original stairs collider for other collisions. For example, we might want small debris to land on the individual stair steps correctly instead of sliding down the ramp. Let's make this possible by adding 2 more layers, one for detailed and one for stairs objects. The probe mask should include the stairs layer, but not the detailed layer. Next, go to the physics section of the projects. Now enable the stairs mesh collider components again, then add a few small rigid body objects on top of them to see both. Okay. I feel like this is... like we could just skip this part.
I mean, he's just... well...
Up until, like, max stairs angle. If we're able to climb stairs, it makes sense that we use a different max angle for stairs than for normal ground. Oh, okay, so it's...
I'm kind of interested in... is he doing, like, layers for different, like...
collider layers.
I'd like to know about that. I feel like that would be...
Yeah.
That's something that would be
like
worth practicing.
Really explain it, though.
Okay.
But we'll just go through it, I guess.
I wanted to set up stairs.
So you just make shapes. You just make the shapes over the stairs, and then you can convert them to a collider.
I think these are just too steep. Okay.
So it's here. It's in the layer collision matrix. So you have to go to project settings, physics, and then there's a layer collision matrix that you choose, like, what stuff interacts with what. Yeah. So you could say agent doesn't interact with agent. So detailed... is detailed the detailed stairs or the detailed objects, you think?
What do you mean? Is that a list on the layers?
Oh no, there is a stairs. Never mind. Well, actually, I don't know. He has a detailed layer and a stairs layer.
Did he make that, or is that just default?
No, he added them. We might want small debris to land on the individual stair steps correctly instead of sliding down the ramp. Let's make this possible by adding 2 more layers.
So yeah, one is the like more detailed hitbox, and the other one is the simplified one, and it's just like rigid bodies interact with the detailed one, whereas like a player character would interact with the simplified one, I guess.
He says 1 for detailed and 1 for stairs objects. Probe mask should include the stairs layer, but not the detail layer. So the probe mask, okay, yeah, you're right. The probe mask checks the stairs, checks the flat plane, or the like flat slope, but not the steps.
Why does it still fly off like a ramp?
You saved in a while.
Well, so he puts. I guess his does that too, huh? But he put his acceleration up to 100. Okay, I thought it was gonna just. Oh, that's not. That's never mind. Okay.
What was it?
Because that's the problem with the stairs thing, right? Is that it doesn't actually treat it like a ramp. So then after he treats it like a ramp, then it sticks to it like it should.
Oh yeah.
So now I just have to create.
I feel like mine isn't even snapping to these though. On the old one. I guess it is.
It depends on your snap. Is your snapping angle like less than your max speed? It should be a little bit more than your max speed.
Max ground angle.
Or I'm sorry, what is it called? Max snap speed should be a little bit more than your max speed.
Okay.
So I have my max snap speed to 12, and then my max speed at 10, and with that, it like goes over the slopes properly.
Well, it's the same.
Oh, you see it on my
Does this look like
screen?
it's snapping? Yeah, mine's not doing that. Look.
What is your snap speed set to?
Same 12, 10,
What about like your acceleration?
10.
And you have it set for all of them?
Oh no. I don't think I. Wait, did I? Yeah.
You have to like select all of them and then change it
Yeah,
for
I
it to
did.
play. Okay. Hold on. Let me. I gotta
What's your
fuck with your
ground
window.
angle?
I can't like see on your screen very well right now. I have to fix my OBS thing real quick. Okay.
Is it cause? Wait, what the fuck? Is it this layer thing? Or should I? Thought that I put all these spheres to agent, but I guess not.
Are they not all set to agent?
No.
That could be a problem, yeah. And then also the probe mask, did you set all of them to be specifically on the right things, you know what I mean? So I deleted, I only have one sphere now. I deleted all of mine.
Max ground angle at?
My max ground angle, it's at 45.
Okay, I think that's what it is. Because it seemed like it was doing it for the two low ones. Let me see. No, it's the same. What the fuck? I wonder what I'm missing here.
Here, I'll send a grab of what my moving sphere settings look like.
Oh wait, step since last grounded just keeps going up. So there's something wrong with that.
Oh, so it's probably something in code.
Yeah. Something's messed up.
Let's compare our scripts.
Steps since last grounded.
So I have steps since last grounded defined first, and then oh wait, where'd it go? It's defined, and then in bool snap to ground, it's used in a comparison if less than 1.
Oh wait, yeah, I never put it. I don't have it isn't set to 0 anywhere. I don't think I wrote that line.
It should be set to 0 in update state under the if on ground or snap to ground. It should be set to 0 there.
Yeah, it's not there. Forgot that.
Okay. How did you see that value was just like constantly climbing?
It's a serialized field.
Oh, so you can just look on.
It shows it.
Okay.
Yeah. I feel like I did this somewhere else. No. Yeah.
There you go. It works when just like walking off a slope too. That was something I was worried about. If you just walk off of a ledge like that, I was thinking it would just like snap you straight to the ground immediately.
New shape, stair. You just did the one set of stairs, right?
I did a few. I just did like higher and higher step count like this. And then I like also mirrored it and flipped it so that it's like a ramp. Yeah, I mean we're at an hour, so we could leave off at Simplified Collider. That's about halfway, which is actually surprising.
Where is that?
2.1.
Oh, okay.
That's
yeah,
like right
honestly,
halfway, basically.
I'm down with that. I'm pretty tired.
Yeah, me too. But yeah, so tomorrow I'll set up the actual like collider. We'll go through all the physics layers stuff, and then whatever all this is. Ooh, wall jumping. That'll be fun. Okay, yeah, tomorrow looks like it could be an interesting day because the collider thing is definitely something we're gonna have to deal with a lot. Is like taking a mesh and then creating a collider to represent that mesh, so it doesn't have to be like a super complicated collider. Like that's something we need to know for sure.
Yeah.
And then
being able to trick people like that is really good.
And then physics, the whole like physics layers thing. That sounds like that. I don't have like any ideas that pop out in my head immediately for that, but that sounds like it's something, you know. It sounds like it could go somewhere. Wall jumping, self-explanatory. That's fucking awesome. Air jumping after you wall jump, I guess, is what that is. Oh, you could do the jumping back and forth between two different walls thing too. The like Mario Sunshine thing. That's sick. So yeah, that's gonna be a fun one. So hopefully we'll wrap up Surface Contact tomorrow, because we did half of it in an hour today, but odds are the second half is going to be a little bit more complicated, but we'll also be a little more motivated tomorrow, I think. So I think we were both feeling a little tired today.
Gonna get a good sleep.
Yeah. All right. Well, we're gonna end it there. Goodbye bye.
Good night.